Let us examine recursive formulas for arithmetic sequences. We're going to look at the steps that we use or that are required or that are necessary to derive the recursive formula for arithmetic sequences. Let's walk through the steps. The first thing we want to do is identify the first term. We give that the letter A. We want to identify a difference or the difference between each successive term and the previous term. We call that D. And then we want to write the formula in this form. Let's take a quick look at the way the formula looks. So we have A, which means that n equal to 1. So that's your term is the first term. And then for every other term, note that n is always going to be a whole number. So for every other term, we're going to add the previous value to the common difference between each successive term. So let's go ahead and take a look at some examples. So the first thing we want to go ahead to do is identify the first term, A. So let's go here, say A equal to 1. Now let's look at the difference between each successive terms. So we look at 2 1 over 3 minus 4 1 over 3. So that's going to give us negative 2. So the difference between each successive term is negative 2. So D is equal to negative 2. So now let's go ahead and plug this in the function that we have here. So f of n is equal to A is 1, and then we have f of n minus 1 minus 2, and here it's 1. Actually, A is actually 4 1/3. So this is 4 1/3 when n equal to 1, and it's f of n minus 1 minus 2 when n is greater than 1. Let's look at another example. So we look for the value of A is negative 3. Now let's look at the difference between each successive term. So D is going to be equal to negative 7 minus negative 3, which must also be equal to negative 11 minus negative 7. So you do this just to confirm that it's a common difference. So we have negative 4. So let's look at our g of n is equal to A is negative 3, and then we have g of n minus 1 minus 4. This is true when n equal to 1. This is when n is greater than 1. So this is how you get your value. Now let's look for g of 6. So g of 6 is going to be equal to g of 6 minus 1 minus 4, which is g of 5 minus 4. So g of 5 is negative 19 and then minus 4, which is equal to negative 23. So g of 6 is equal to negative 23. Final example here, we start by looking for our first term. A is equal to 6. Let's look for our common difference. So we have 5 1/3 minus 6, and then let's just so that we can get through this quickly, this is 5 1/3 minus 5 3 over 3, which is negative 2 over 3. So that's our common difference. So our P of n for this function, the recursive formula is going to be, so A is 6, and then we have P of n minus 1 minus 2 over 3. Here this is where n equal to 1, and here n is greater than 1. Now let's look for P of 7. So P of 7 is going to be P of 6 minus 2/3. We don't have a value for P of 6, so P of 6 is equal to P of 5 minus 2/3 minus 2/3. So this is going to give us P of 5 minus 4 over 3. So P of 5 is 3 1/3 minus 4 over 3, which is going to give us 10 over 3 minus 4 over 3, which is 6 over 3, which gives us a value of 2. So P of 7 is equal to 2.